videos over the past couple of months, you may have noticed that I've been wearing this t-shirt with a strange symbol on it, and it's made up of this long string of numbers. Well, you may not notice that it's made up of a long string of numbers, but I'm telling you, the symbol is made up of a long string of numbers. Well, these are my mathematical constant shirts. The symbol is mathematical constant, and the long string of numbers is an incredibly accurate approximation of that mathematical constant. I have 3 of these shirts. Now, what is a mathematical constant? I pretend that you ask. Well, I'm glad you did. You see, a mathematical constant is an irrational number that shows up a lot in mathematics. An irrational number is just a number that goes on forever without really repeating itself. Now, there are 3 of these mathematical constants that I know of, 1 to go with each shirt. So, in 3 separate videos over the course of the next several weeks, I will be explaining each of these mathematical constants. Today is pi, definitely the most famous of the mathematical constants. Now, pi is a common number, and you guys have probably heard a lot about it, and most likely you know that it has a lot to do with circles. So, some of the stuff I'm going to tell you, you probably already know. But, if you didn't know, the pi is the ratio of the circumference of a circle to its diameter. Now, the circumference of a circle is the outermost edge of the circle. Like in blue, that's the circumference. The diameter, then, is a line from one edge of the circle through the center point to the other edge. So, if we take our circumference and divide it by our diameter, we get pi. Now, while the sizes of circles may change, this ratio remains constant. And as such, we can just multiply the diameter both sides, and we get that the circumference equals the pi times the diameter. So this way, if we ever have the diameter, we can now figure out the circumference of the circle. And, since the diameter is equal to twice the radius, we can also set up this formula if we have the radius. So we have the circumference equals 2 times pi times r. And this is an incredibly useful formula to have. Pi, of course, has uses just beyond the circumference of a circle. It's also good for the area. And the equation for that is a, for area, equals pi times r squared. So if you ever want to find the area of a circle, you just use that. Now, of course, what if you want to move beyond the second dimension, get into 3 dimensions? Pi's got you covered there, too. So say you have a sphere, like this, you can use pi to figure out the surface area of the sphere. And the surface area is just 4 times pi times r squared. But what if you want to find the volume of the sphere? Well, pi's got you there as well. The volume of the sphere is just 4/3 times pi times r cubed. Now, of course, pi isn't just for the circles or spheres. It can also be used for, like, say, cylinders, or maybe even cones, or those weird kind of cone things that are, like, tilted like this. Now, I'm not going to go through all of the equations for these. You're on the internet, so if you're desperately curious, you can just go look them up. But pi is used for all of these, in pretty much anything with a circle, because cylinders and cones, you'll notice, have circle bases. So, pi is incredibly useful for all of your circle-related needs. Now, you may be wondering, well, what is pi? I mean, I've told you what it's used for, but I haven't really told you what it is. Well, I've told you that it's the ratio of the circumference to the diameter, but if you're looking for a numerical value, that really doesn't help you. We really don't have a numerical value for pi. We have approximations, but we don't have the actual value of pi. An incredibly popular approximation is 3.14. That's by far the most popular. Another popular one is 22/7. I personally know pi to 16 digits, and those are 3.14159 265,358,973. So I know pi to 16 digits, these being the 16 digits. And then another fairly popular approximation for pi is if we take 4 and then multiply it by the quantity 1, minus 1/3, plus 1/5, minus 1/7, plus 1/9, minus 1/11, and so on. And that will give us another fairly close approximation for pi. But we don't have an actual value for pi, because pi goes on forever, so we can only get approximations. Now, we do not need an actual value of pi, and here is why. Now, the width of the observable universe is 93 billion light years. So that is the width, or diameter. Now, a light year is the distance light will travel in a year. So, if we take the years and convert that into seconds, and then multiply it by the speed of light, we get approximately 8.8 times 10 to the 26th meters. The actual value is lower than this, but since this is the width of the observable universe, which is the biggest possible thing we can imagine, or that we can even see, for that matter, rounding up a little doesn't hurt, because we're going to figure out the number of digits we have, and rounding up, again, does not hurt. So this is the biggest possible thing in the universe. The universe. Now, the smallest possible thing in the universe is accepted by scientists to be a Planck's length. Now, a Planck's length is 1.616 times 10 to the negative 35 meters. Approximately. And this is accepted by scientists to be the smallest possible distance. Now, we want to figure out the circumference of the universe within one Planck's length. So we are going to figure out the circumference of the biggest possible thing within the distance of the smallest possible thing. So we do not need any more accuracy than this. We do not need to go, because anything else we will be finding the circumference of will be smaller than the biggest possible thing, and we won't need it to as much accuracy as the smallest possible thing. So this is the most accuracy we will ever need. This is what I'm trying to get across. Now, so we want the circumference of the universe, the circumference of the actual universe, so I'm going to do that, the circumference of A, minus the circumference of our approximation, which I should also put as A, but since I don't know that, I'm going to put as question mark. So we want this difference between those circumferences to be 1 Planck's length. So, now if we were to use our handy circumference equals the diameter times pi equation, we can go about solving this. So we have our d times pi actual minus our diameter times our pi approximation. We still want that to equal 1 Planck's length. And we can divide a d out to both sides. So d cancels from all of this. So we're now left with the actual pi minus the approximation of pi. And that needs to equal 1.616 times 10 to the negative 35 over 8.8 times 10 to the 26th. And this fraction is approximately 1.837 times 10 to the negative 62. So, this difference between actual pi and our approximation of pi, to get it within 1 Planck's length, will be this. Now, what that means is that we need 62 digits of pi to get the circumference of the universe within 1 Planck's length. So as such, the trillions of digits that have been calculated on computers are completely unnecessary. And for everyday uses, the 16 digits I've memorized is more than enough. So, we really don't need the actual value of pi. An approximation to 62 digits is going to be fine in every circumstance. Now, the last thing I want to let you know is that pi does not necessarily need to relate to circles. There are actually several equations involving pi that have nothing to do with circles. My favorite, and arguably the most popular, is e to the I times pi plus 1 equals 0. Now, technically, these are all numbers, so it isn't really much of an equation. Most equations have variables in them, but it is still a very cool relation between 5 popular mathematical numbers, and it has nothing to do with circles. If you want to know more about this, I've made a video about it, which I will link to. You can just click on here. So I just want to let you know that pi has equations beyond just relating to circles. But yeah, so that was my pi video. Now, this is by no means everything about pi. I mean, I'm certain there are several facts about pi that I had no idea about. So, if you're curious about pi, I encourage that after this video, you go online and search more about it. I mean, my goal for these videos is to tell you what the constant is, and then what it's used for, and hopefully I've accomplished this here. Now, the next mathematical constant video will be up in a couple of weeks. And if you're curious as to what it might be, I'll give you a hint. It was shown in this week's video. Good luck. But yeah, I hope you enjoyed it, hope you learned something, and see ya!